December 17, 1944. The frost-bitten morning air above the Ardennes carried the metallic scent of aviation fuel and the distant rumble of German artillery. Captain Edwin Cottrell gripped the controls of his P-47 Thunderbolt, watching ice crystals form on his windscreen as he climbed through 7,000 feet. Below, the snow-covered forests of Belgium stretched endlessly, hiding Wehrmacht divisions that would soon unleash Hitler's final gamble. Above, the sky belonged to him and his fellow Thunderbolt pilots. 8 tons of American steel wrapped around a Pratt & Whitney, our 2800 double Wasp engine, 18 cylinders of raw power that could deliver over 2,000 horsepower. What Cottrell could not know, as he banked toward his assigned patrol sector, was that within minutes his aircraft would lose half its engine to German cannon fire, yet still carry him home through a miracle of American engineering and industrial might. The Republic P-47 Thunderbolt had entered service barely 2 years earlier in 1942, but by this winter morning of 1940, it had already earned a reputation that sent ripples of dread through Luftwaffe squadrons across Europe. Alexander Kartvel's massive fighter was more than an aircraft. It was a flying testament to America's industrial capacity, a symbol of abundance that German pilots could neither match nor fully comprehend. While their homeland endured rationing and desperate material shortages, American factories continued pouring forth these mechanical behemoths, each one representing resources that would have equipped an entire German squadron. The Thunderbolt weighed nearly twice as much as a Messerschmitt Bf 109, carried 8 50 caliber machine guns instead of the typical German armament of 2 cannons and 2 machine guns, and possessed a fuel capacity that allowed it to escort bombers to targets deep within the Reich and return safely to English airfields. 4 German fighter pilots, who had begun the war with absolute confidence in their superior training and aircraft, the Thunderbolt represented a harsh awakening to new realities. Oberleutnant Franz Stigler of JG-27 would later recall his first encounter with the formation of P-47s over France in April 1943. "We expected to bounce them easily. They looked like flying milk jugs, so fat and ungainly. Our 109s were sleek racehorses compared to these American monsters. But when we dove on them, they simply absorbed our fire and kept flying. Then they turned toward us, and we saw those 8 gun barrels in their wings. The sound they made when they ferreted was like thunder. We learned quickly not to underestimate the jug." The Germans had entered World War II with fighters designed for short-range interception and dogfighting aircraft that reflected their nation's tactical thinking and resource limitations. The Messerschmitt Bf 109 carried fuel for perhaps 90 minutes of flight time, armed with 2 rifle-caliber machine guns and a single cannon firing through the propeller hub. Its design philosophy emphasized agility and climbing performance characteristics that had served well in the early war when Luftwaffe pilots enjoyed numerical superiority and could choose their engagements. But by 1943, as American bombers began arriving over German territory in ever-increasing numbers, that tactical luxury had vanished. German fighters now faced the grinding reality of attrition warfare against an enemy whose resources seemed limitless. The P-47 embodied American strategic thinking and industrial capability. Where German designers had prioritized weight savings and fuel efficiency, Republic Aviation had simply built the fighter around the largest, most powerful engine available to Pratt & Whitney, our 2800 double Wasp. This 18-cylinder radial power plant weighed over 2,300 pounds by itself, more than entire German fighter engines, yet delivered horsepower ratings that dwarfed European competitors. The Americans had wrapped this massive engine in armor plating, surrounded it with fuel tanks containing nearly 400 gallons of aviation gasoline, and mounted 8 heavy machine guns in wings strong enough to carry a ton of bombs. The result was an aircraft that weighed nearly 4 tons fully loaded, yet could reach speeds exceeding 430 miles per hour and climb to operational altitudes above 40,000 feet. German pilots quickly discovered that conventional fighter tactics proved ineffective against Thunderbolts. Major Heinz Barr of JG-1, who had finished the war with 220 confirmed victories, encountered his first P-47s during the summer of 1943 and found his usual approach a high-speed diving attack, followed by a climbing turn to reset for another pass completely neutralized by the American fighter's characteristics. The Thunderbolt could outdive anything we had, Barr later explained. If we tried to escape by diving, they followed us down and caught us. If we tried to climb away, their heavy firepower could reach us before we gained safe altitude. They forced us to fight on their terms, not ours. The psychological impact proved as significant as the tactical challenges. German pilots had grown accustomed to aircraft that required careful fuel management, ammunition conservation, and precise timing to achieve success. A Bf-109 pilot typically carried 60 rounds per cannon and 500 rounds per machine gun, enough for perhaps 15 seconds of sustained fire. In contrast, a P-47 pilot entered combat with 3,400 rounds of 50 caliber ammunition, sufficient for over 30 seconds of continuous firing from all 8 guns. The disparity in firepower meant that German pilots had to achieve precise killing shots on their first pass, while American pilots could afford to engage in prolonged combat, spraying bullets until they achieved hits. Lieutenant Colonel Robert S. Johnson of the 56th Fighter Group experienced this abundance firsthand during his combat tour over Europe. As he would later recall in interviews, the first time I fired all 8 guns together was in actual combat. We'd only trained with 2 guns at a time because ammunition was too precious to waste. When I finally pulled the trigger on a German fighter, the vibration was so intense I thought I'd been hit. Fire and smoke poured over the wings, the whole airplane shook, and I let go of the trigger immediately. Then I saw the enemy aircraft ahead of me coming apart, and I realized that this was one target that wasn't going to just keep flying along normally. The Pratt & Whitney R-2800 engine that powered the Thunderbolt represented American engineering at its finest and most abundant. This massive radial featured 2 rows of 9 cylinders, each precision machined from high-grade aluminum alloys that German industry could no longer afford to allocate to aircraft engines. Each cylinder head contained 4 valves operated by a complex mechanism of pushrods, rocker arms, and springs that required metallurgy and manufacturing tolerances far beyond what German factories could achieve by 1943. The engine's magnesium crankcase alone weighed more than an entire German motorcycle, yet was machined to tolerances measured in thousandths of an inch. For Luftwaffe mechanics struggling with ersatz materials and substitute alloys, the R-2800's abundance of high-quality components seemed almost wasteful. German engines increasingly relied on steel components, where aluminum had once been used, wooden parts replacing metal ones, and synthetic oils of questionable quality. Maintenance intervals stretched from the peacetime standard of 50 hours to over 200 hours as spare parts became scarce. In contrast, American ground crews serviced their R-2800 engines with an abundance of genuine replacement parts, high-grade lubricants, and specialized tools that German mechanics could only dream of possessing. The engine's 18 cylinders provided redundancy that German power plants could not match. A typical German inline engine, like the Daimler-Benz DB6-05 powering late-war Messerschmitts, featured 12 cylinders arranged in a V configuration, with cooling provided by a vulnerable radiator system. Battle damage to the cooling system meant almost certain engine failure within minutes. But the R-2800's air-cooled design eliminated the radiator vulnerability, while its numerous cylinders meant that damage to several units still left enough power for sustained flight. This redundancy became legendary among P-47 pilots who returned from missions with engines that should have been impossible to operate. Captain Francis Gabreski of the 56th Fighter Group once landed with 3 cylinders completely destroyed by German cannon fire, their heads blown clean off and oil streaming from the devastated power plant. The remaining 15 cylinders continued producing enough power to bring him home. Lieutenant Edwin Wright returned to base with a hole large enough to crawl through, punched in his engine, cowling 5 cylinders, damage beyond recognition, yet still generating sufficient thrust for a normal landing. These incidents became psychological warfare as much as physical combat. German pilots, who had grown up with engines that required careful treatment and precise maintenance, witnessed American fighters absorbing damage that would have downed any Luftwaffe aircraft then flying home as if nothing had happened. The Thunderbolt's ability to sustain massive battle damage and continue operating challenged German assumptions about American industrial quality and pilot training. Hauptmann Johannes Steinhoff of JG-52, who would become one of Germany's highest-scoring aces, encountered a formation of P-47s during the summer of 1944 and scored direct hits on the lead aircraft with his cannon. "I saw my shells explode on the engine cowling," he later recalled. "Pieces flew off, smoke poured out, and I was certain the American would go down immediately. Instead, he continued flying straight, and level even accelerated slightly. I fired again, more hits on the engine, more debris flying. Still, he flew normally. It was unbelievable. In a 109 or 190, those hits would have meant immediate engine failure and a dead stick landing at best." The R2800's construction incorporated design features that European engines had been forced to abandon due to material shortages. Each cylinder featured a forged aluminum head with deeply finned cooling surfaces, maximizing heat dissipation while minimizing weight. The valve guides were made from bronze alloys that contained copper, increasingly rare in German industry, while the valve seats were hardened steel inserts that required specialized heat treatment. The pistons themselves were forged aluminum alloy components, featuring complex cooling galleries and precisely machined ring grooves that German factories could no longer produce to such exacting standards. American abundance extended beyond individual components to entire manufacturing processes. Republic Aviation's factory in Farmingdale, Long Island operated 3 shifts daily, turning out completed P-47s at a rate of 5 aircraft per day by 1944. Each airplane required over 150,000 individual parts, from massive forged wing spars to tiny electrical connectors, all manufactured to specifications that maintained interchangeability between aircraft. German production, by contrast, increasingly relied on hand-fitting and custom modifications as standardized parts became unavailable. The psychological impact of this abundance manifested itself in pilot confidence and tactical aggressiveness. American P-47 pilots entered combat knowing that their aircraft represented the finest materials and craftsmanship their nation could provide, that spare parts and replacement engines awaited them at their home bases, and that their nation's industrial capacity could replace any losses they might suffer. German pilots, meanwhile, flew increasingly desperate missions in aircraft patched with whatever materials could be found, powered by engines running on synthetic fuel of questionable quality, knowing that each loss brought them closer to ultimate defeat. Captain Charles London of the 78th Fighter Group experienced this abundance in tangible ways during his combat tour. "Our crew chiefs would change spark plugs whenever they felt like it," he recalled years later. 18 cylinders meant 36 spark plugs per engine, and we had boxes of new ones sitting in the maintenance tent. The Germans were pulling plugs from wrecked aircraft and cleaning them for reuse. Our mechanics would replace an entire cylinder head if it showed the slightest sign of damage. We had warehouses full of spare parts while they were manufacturing pieces from scrap metal. The sound of a P-47's R-2800 engine became a psychological weapon in itself. The 18-cylinder radial produced a distinctive deep-throated roar that carried for miles, announcing the approach of American fighters long before they appeared visually. German ground troops learned to recognize this specific engine note and sought cover immediately, knowing that Thunderbolts often carried bombs and rockets in addition to their formidable gun armament. The sound represented American industrial might, made audibly a mechanical symphony that could be produced only by a nation with unlimited resources and absolute confidence in its technological superiority. Luftwaffe pilots developed a grudging respect for the Thunderbolt's durability that bordered on superstition. Major Wilhelm Batz of JG-52, credited with 237 victories, admitted in post-war interviews that he had seen P-47s absorb damage that defied comprehension. "I once scored hits on a Thunderbolt's engine with every shell in my ammunition load," he recalled. 30mm and 20mm cannon shells, each one capable of destroying any German fighter engine. The American aircraft trailed smoke and oil, pieces of cowling flew off with each hit, yet it continued flying in formation with its squadron mates. When we landed, my mechanic counted the empty shell cases. 68 rounds fired, and I had scored hits with most of them. That Thunderbolt should have been a burning wreck, but it flew home to England. The symbolic importance of these engine survival stories extended far beyond their immediate tactical impact. Each P-47 that returned home with massive engine damage represented American industrial capacity triumphing over German precision. The Thunderbolt could afford to be built with redundancy and massive over-engineering because American factories had unlimited access to aluminum, steel, and precision manufacturing equipment. German designers, forced to optimize every component for minimum weight and maximum efficiency, produced elegant fighters that could not survive the brutal realities of sustained combat against an enemy with limitless resources. By late 1944, as Captain Cottrell climbed through the winter sky above the Ardennes, the psychological warfare of abundance had achieved strategic significance. German pilots, who had begun the war with confidence in their superior training and aircraft, now faced the grinding reality of attrition against an enemy whose resources seemed infinite. Every formation of P-47s represented dozens of tons of high-grade aluminum, thousands of precision-manufactured components, and industrial capacity that Germany could no longer match. The Thunderbolt's 850 caliber machine guns embodied this abundance in their most lethal form. Each gun weighed 64 pounds and fired bullets, weighing nearly 2 ounces at muzzle velocities exceeding 2,900 feet per second. A 1-second burst from all 8 guns sent nearly 50 pounds of lead and steel downrange, more firepower than an entire German fighter squadron could deliver in the same time period. The ammunition belts themselves represented American manufacturing prowess. Each 50 caliber cartridge required brass casings, precisely measured powder charges, and armor-piercing projectiles manufactured to tolerances that ensured reliable feeding and firing. German pilots quickly learned that surviving an encounter with P-47s required tactics that would have been considered cowardly in the early war years. Hit-and-run attacks became the norm, with Luftwaffe fighters diving through American formations at maximum speed, hoping to score quick kills before the Thunderbolts could bring their massive firepower to bear. Extended dogfighting became suicidal against aircraft that could absorb tremendous damage while returning devastating fire. Oberleutnant Walter Krupinski of JG-52, who survived the war with 197 confirmed victories, developed tactics specifically for engaging P-47s that emphasized the psychological impact of their durability. "We learned to ignore engine hits on Thunderbolts," he explained in post-war interviews. "You could blow pieces off their engines all day long, and they would keep flying. The only way to bring one down was to kill the pilot or destroy the flight controls." This meant precision shooting at small targets, while avoiding their return fire nearly impossible in the heat of combat. The R-2800 engine's ability to continue operating with severe damage stemmed from design philosophy that prioritized redundancy over efficiency. The 18 cylinders meant that losing 3 or 4 to battle damage still left adequate power for sustained flight. The air cooling system eliminated vulnerable radiators while providing multiple pathways for heat dissipation. Even with several cylinders, destroyed the remaining units could maintain engine temperatures within acceptable limits long enough to reach friendly territory. This durability translated into pilot survival rates that demoralized German fighter units. American P-47 pilots who took hits that would have meant certain death in German aircraft routinely returned to base, underwent brief medical treatment if necessary, and returned to combat within days. The cumulative effect meant that experienced American pilots accumulated combat knowledge and tactical skill, while their German opponents faced constant attrition of their most experienced airmen. The winter of 1944 brought these realities into sharp focus as the Battle of the Bulge tested both sides' remaining resources. German forces committed their final reserves of men and material to Hitler's desperate offensive, knowing that failure would mean inevitable defeat. American forces, meanwhile, could draw upon industrial capacity that continued expanding even as combat raged across Europe. Every P-47 lost could be replaced within days by new aircraft rolling off production lines in Long Island. Every R-2800 engine destroyed could be substituted by spare units warehoused at supply depots across England. The symbolic power of the 50 caliber machine gun extended beyond its mechanical characteristics to represent American industrial democracy in action. These weapons had been mass-produced by workers in factories across the American Midwest, assembled by hands that had never known the shortages and deprivations that German workers endured daily. Each gun represented not just superior manufacturing capability, but the moral authority of a nation fighting for freedom against tyranny. Captain Cottrell's encounter with German fighters on December 17th would demonstrate these principles in their most dramatic form. As Messerschmitt Bf 109s dove on his formation from altitude advantage, their cannon shells found his engine cowling with devastating accuracy. The 20mm explosive rounds that struck his R-2800 should have resulted in immediate engine failure and probable death. Instead, the massive radial continued producing power even as cylinder heads disintegrated and oil sprayed across his windscreen. The abundance built into every component of his aircraft, from redundant ignition systems to over-engineered crankcase construction, provided the margin of survival that German pilots could no longer expect from their increasingly desperate machines. The psychological impact of these engine survival stories rippled through both air forces in ways that transcended their immediate tactical significance. For American pilots, each successful return from missions with severely damaged engines reinforced their confidence in their equipment and their nation's industrial supremacy. They entered combat knowing that their aircraft had been built with every advantage that unlimited resources could provide. For German pilots, witnessing the Thunderbolt's ability to absorb punishment that would destroy their own fighters became a daily reminder of their nation's declining fortunes and dwindling resources. Hauptmann Erich Hartmann, who would become history's highest-scoring fighter ace, with 352 confirmed victories, encountered P-47s repeatedly during 1944 and developed profound respect for their durability. The Thunderbolt was not the most maneuverable fighter we faced, he observed years later, but it was certainly the most difficult to destroy. You could hit the engine repeatedly with cannon fire and watch pieces fly off, yet the aircraft would continue flying normally. It forced us to reconsider everything we thought we knew about aerial combat. The R-2800's 18 cylinders represented more than mechanical redundancy. They embodied American abundance, made manifest in aluminum and steel. Each cylinder required precision machining to tolerances measured in thousandths of an inch, metallurgy that demanded high-grade alloys, and assembly techniques that presupposed unlimited access to specialized tools and skilled workers. German industry, increasingly reliant on slave labor and substitute materials, could no longer match such manufacturing standards even when blueprints were available. American ground crews servicing P-47s operated with an abundance that seemed almost wasteful to observers accustomed to wartime shortages. Mechanics routinely discarded spark plugs that showed minor fouling rather than cleaning and reusing them. Entire cylinder assemblies were replaced for damage that German mechanics would have spent days repairing. Oil changes occurred at intervals that European air forces would have considered extravagant, using lubricants refined to specifications that German synthetic oil could never achieve. This maintenance philosophy translated directly into operational reliability and pilot confidence. American P-47 pilots knew that their engines had been maintained to peacetime standards using genuine parts and high-grade consumables. They could push their aircraft to maximum performance limits without fear of mechanical failure, knowing that every component had been built and serviced with unlimited resources. German pilots, meanwhile, flew aircraft maintained with substitute parts and ersatz materials, never certain when mechanical failure might occur at the worst possible moment. The sound of mass P-47 formations became the audible signature of American air power over Europe. Dozens of R-2800 engines operating in formation produced a mechanical symphony that announced American presence from many miles away. This distinctive roar represented not just immediate tactical threat, but the broader strategic reality of unlimited American industrial capacity applied to warfare. Each engine note represented tons of strategic materials, thousands of man-hours of skilled labor and manufacturing techniques that German industry could no longer duplicate. German civilians learned to recognize the P-47's engine sound and associate it with a broader American bombing campaign that was systematically destroying their nation's infrastructure. The deep-throated roar of massed R-2800 engines often preceded formations of B-17 and B-24 bombers that would reduce German cities to rubble. The Thunderbolt's distinctive engine note became the acoustic prelude to destruction on a scale that German industrial capacity could neither prevent nor repair. By December 1944, as winter fighting intensified over the Ardennes, these symbolic meanings had achieved strategic importance that transcended individual combat encounters. Every P-47 that returned to base with severe engine damage represented American industrial supremacy made visible. Every German fighter shot down by Thunderbolt firepower demonstrated the futility of opposing unlimited resources with limited ones. The mathematical reality had become inescapable. American factories could produce aircraft faster than German pilots could destroy them. The Pratt & Whitney R-2800 that powered Captain Cottrell's P-47 on that December morning embodied these broader realities in 18 cylinders of American engineering excellence. As German cannon shells found their mark and began destroying individual cylinder assemblies, the engine's fundamental design philosophy of abundance and redundancy provided the margin of survival that would bring him home. The same cylinders that German mechanics would have spent weeks attempting to repair were simply written off as acceptable losses, replaceable by spare parts already waiting in supply warehouses across England. The moment of impact came without warning as 20mm cannon shells from a diving Messerschmitt found Cottrell's engine cowling. The explosive rounds that struck the R-2800 should have meant immediate catastrophic failure, but American over-engineering transformed certain death into manageable emergency. Cylinder heads disintegrated in showers of aluminum fragments, oil lines ruptured and sprayed lubricant across the windscreen, yet the massive crankcase continued rotating, and the remaining cylinders continued firing. The abundance built into every component provided redundancy that kept the engine operating even as pieces flew off in the slipstream. This was the moment when American industrial philosophy met German desperation in the most direct possible terms. The cannon shells that struck Cottrell's engine represented the finest ammunition that German industry could still produce. A precision-manufactured explosive rounds fired from weapons that embodied decades of European engineering excellence. Yet they proved insufficient to stop an engine that had been designed and built with unlimited resources and absolute confidence in American manufacturing supremacy. The oil that sprayed across Cottrell's windscreen as his engine absorbed punishment represented another aspect of American abundance. The lubricant that German pilots carefully conserved and recycled was simply written off as an acceptable loss, replaceable from seemingly unlimited supplies warehoused throughout the European theater of operations. American mechanics would refill the engine with fresh oil and replace damaged components without considering the cost, while German maintenance crews mixed used oil with substitute additives and hoped their engines would continue operating. As Cottrell struggled to maintain control of his damaged aircraft, the psychological warfare of abundance achieved its most personal dimension. The same engine that German pilots had learned to fear for its durability was now demonstrating that durability in the most extreme circumstances possible. Even with significant portions of its cylinder assemblies destroyed, the R-2800 continued producing enough power to maintain flight. This was American industrial might reduced to its most basic terms: raw mechanical superiority that could absorb devastating damage and continue operating. The surviving cylinders of Cottrell's engine continued their precise mechanical dance, even as their destroyed neighbors leaked oil and coolant into the slipstream. Each remaining cylinder assembly represented hundreds of precision-manufactured components, working in perfect harmony: forged aluminum pistons, riding in machined cylinder bores, hardened steel valves, sealing against bronze valve seats, ignition systems, timed to fractions of degrees. The mechanical precision that kept these components operating under extreme stress demonstrated manufacturing capabilities that German industry could no longer match. The sound of Cottrell's damaged engine changed from the normal deep roar of 18 cylinders to an irregular rumble as destroyed cylinders ceased contributing to the power output. Yet even this damaged mechanical symphony carried symbolic weight. It represented American abundance, operating at reduced capacity, yet still providing adequate performance for survival. A German engine suffering similar damage would have seized within minutes, but the R2800's over-engineered construction provided margins of safety that transformed catastrophic damage into manageable emergency. The flight home became a testament to American engineering philosophy applied to warfare. Each mile covered by Cottrell's damaged P-47 demonstrated the practical advantages of unlimited resources over elegant efficiency. The engine that carried him back to Allied territory had been designed and built without regard for material conservation or manufacturing economy. Every component had been over-engineered to provide maximum reliability and durability, knowing that American industry could afford such apparent waste. The oil pressure gauge that fluctuated wildly as damaged cylinders leaked lubricant told the story of abundance in its most basic form. German pilots monitored oil pressure with obsessive care, knowing that even minor leaks could lead to engine failure within minutes. American pilots like Cottrell could afford to lose substantial quantities of oil and continue operating knowing that the engine's design incorporated safety margins that European aircraft could not match. As Allied territory came into view below his damaged aircraft, Cottrell embodied the broader strategic reality that the P-47 represented. His survival was not just personal triumph, but demonstration of American industrial supremacy applied to individual combat. The engine that carried him home had absorbed damage that would have downed any German fighter, yet continued operating with sufficient power for a normal landing. This was abundance made manifest in aluminum and steel. American resources applied without restraint to ensure victory. The landing approach required careful management of his damaged engine's remaining power, but even this emergency procedure demonstrated American abundance. The air base that welcomed Cottrell's return operated with resources that German airfields could no longer imagine. Unlimited aviation, fuel, complete maintenance facilities, warehouses full of spare parts, and ground crews equipped with specialized tools. His damaged engine would be replaced within hours by a fresh R2800 from supply stocks, while German mechanics would have spent weeks attempting repairs with substitute materials. Ground crews who examined Cottrell's engine after landing found damage that should have resulted in immediate catastrophic failure. 3 cylinder heads had been completely destroyed by cannon fire, their aluminum castings blown away in fragments. Oil lines had been severed, cooling fins destroyed, and ignition components damaged beyond recognition. Yet the engine had continued operating long enough to carry its pilot home, a mechanical miracle made possible by American over-engineering and unlimited resources. The spare parts that would restore Cottrell's P-47 to combat readiness represented the broader industrial capacity that was winning the war in Europe. Each replacement component, from complete cylinder assemblies to individual spark plugs, embodied manufacturing techniques and material qualities that German industry could no longer achieve. The precision machining, metallurgy, and quality control that characterized American aircraft production had become decisive strategic advantages. The psychological impact of Cottrell's survival extended far beyond his individual experience to reinforce broader themes of American industrial supremacy. His fellow pilots who witnessed the damaged P-47's successful return gained confidence in their own equipment and their nation's ability to provide them with superior aircraft. German pilots who learned of such incidents faced growing realization that they were fighting an enemy with resources that defied rational understanding. The R-2800 engine that had carried Cottrell home would be removed from his aircraft and shipped to maintenance depots for analysis and possible repair. American industry could afford such thorough post-battle examination of damaged equipment, using the information gained to improve future designs and manufacturing processes. German forces, meanwhile, could barely maintain existing aircraft with the materials available, much less conduct systematic analysis of battle damage for engineering improvements. The new engine that replaced Cottrell's damaged R-2800 represented American abundance in its most direct form. Fresh from the production line at Pratt & Whitney's East Hartford factory, it embodied the finest materials and manufacturing techniques that unlimited resources could provide. Every component had been precision machined to exacting tolerances, assembled by skilled workers using specialized tools, and tested to standards that German industry could no longer maintain. This cycle of destruction and immediate replacement demonstrated the strategic advantages that industrial abundance provided in sustained warfare. American forces could afford to write off damaged equipment and replace it with new production, knowing that factory output exceeded combat losses by substantial margins. German forces faced the grinding reality of declining resources and increasing demands, forcing them to repair and maintain equipment that should have been replaced. The symbolic power of Cottrell's survival story resonated through both air forces in ways that transcended its immediate tactical significance. For American pilots, it reinforced confidence in their equipment and their nation's commitment to providing them with the finest aircraft possible. For German pilots, it represented another reminder of their declining fortunes and the futility of opposing unlimited American resources with their own dwindling supplies. The winter of 1944 brought these realities into sharp focus as both sides committed their remaining resources to decisive battle. German forces launched their final offensive knowing that failure would mean inevitable defeat, while American forces drew upon industrial capacity that continued expanding even as combat raged. Every P-47 that returned from missions with severe damage demonstrated the practical advantages of abundance over efficiency in sustained warfare. Captain Cottrell's damaged P-47 became a symbol that transcended its individual significance to represent broader truths about American industrial might. The engine that had carried him home despite catastrophic damage embodied the philosophy of abundance that characterized American aircraft production, unlimited resources applied without restraint to ensure maximum reliability and pilot survival. This approach to manufacturing had transformed numerical superiority into qualitative dominance that German forces could no longer challenge effectively. The 50 caliber machine guns that armed Cottrell's P-47 represented another dimension of American abundance applied to warfare. Each gun embodied thousands of precision-manufactured components, while the ammunition they fired required strategic materials and manufacturing capacity that German industry could no longer match. The firepower advantages that these weapons provided had forced German fighter tactics to evolve from aggressive engagement to desperate hit-and-run attacks. As 1944 drew toward its close, the strategic implications of individual survival stories, like Cottrell's, had achieved decisive importance in the air war over Europe. Every American pilot who returned from missions in severely damaged aircraft demonstrated the practical superiority of abundance over efficiency. Every German pilot shot down by overwhelming American firepower represented resources that could not be replaced from declining industrial capacity. The Pratt & Whitney R-2800 engines that powered American P-47s had become mechanical ambassadors of American abundance, their distinctive roar announcing unlimited industrial capacity applied to warfare. Each engine represented tons of strategic materials, thousands of man-hours of skilled labor and manufacturing techniques that embodied the finest achievements of American engineering. German pilots who faced these engines in combat confronted not just superior aircraft, but the visible manifestation of their enemies' unlimited resources. In the closing months of World War II in Europe, stories like Captain Cottrell's survival, with half his engine destroyed, achieved significance that extended far beyond individual heroism. They demonstrated the decisive advantages that unlimited resources provided in sustained warfare, the triumph of abundance over efficiency, and the ultimate victory of American industrial democracy over authoritarian resource scarcity. The cylinder heads that had been blown from his R-2800 by German cannon fire were simply acceptable losses, replaceable by spare parts already waiting in supply warehouses. This was abundance made manifest in aluminum and steel. American industrial might applied without restraint to ensure victory. The echo of those damaged engines carried a message that resonated across the battlefields of Europe. American abundance had transformed warfare itself, making defeat inevitable for any enemy that lacked unlimited resources. In the roar of 18 cylinders, half of them destroyed, yet still producing power, lay the mechanical heartbeat of democracy, triumphant, abundant, resilient, and ultimately unstoppable.